Okay, sorry, just really needed to make sure it was recording this time because I just did this whole thing and my phone wasn't actually recording, so I had to like triple check that it's recording. So yeah, I did all this like 20 minutes ago. Now I gotta do it again. Okay, so first time for you, second time for me. I'm cranky because I've been in this room for 4 hours recording now, and I really wanted to be done, and I was like, yes, I'm done, and like the kids are done, I'm like, woo, we did it, and then I look at my phone, and my phone's just off. It's just off. So, yay. I'm gonna do it again now. So, congruent parts, congruent, not recording, not starting over again. This is unhinged. CP, congruent parts of congruent triangles are congruent. Okay, we saw that before. Why is it important though? What do we use it in proofs for? Okay, so if we look at this one right here, I'm trying to prove that a part is congruent. Every single proof we've done so far has been the triangle is congruent. Why is the triangle congruent? Is it side, side, side? Is it hypotenuse, leg? Is it all of these things? It doesn't, I don't know, but that's what it was asking. Now it's saying a part is congruent. It's saying this angle is congruent to that one. So in order to do that, we're gonna end up using CP/CTC by saying that, well, the parts are congruent, but before we do that, before we can, we need to make sure that we prove that the triangles are congruent first. I have to make sure that triangle A matches triangle B before I can say that the corners match on it, okay? So in example 1, I filled some stuff in. Let's label the picture. It says that AB is congruent to AD. Boom, boom. It says that BC is congruent to DC. Boom, 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 boom. Okay. All right, so I've labeled it. I've got my free points, but that's talk. I'm trying to prove that a part is congruent, and we just said that if I'm trying to prove a part is congruent parts congruent, triangles are congruent, I'm gonna use this. If I'm proving a part, an angle or a side congruent, I'm gonna use this. But before I could say this confidently, there was something I needed to do. I needed to prove that the triangles are congruent. So the line before, the statement before, the part is congruent, I need to say that the triangles are congruent. So triangle A, B, C is congruent to triangle A, D, C, okay? Now, I know that that's the statement. I know that the triangles are going to be congruent, but I don't know why yet. I don't know if I'm going to put angle, side, angle, or side, side, side. I don't know what goes here yet, but I know that those red boxes get filled because logically, that's the only option I had. All right, I labeled my picture, and I hope you recognize that there's a side that they share. And if there's a side that they share, you better put it in the box, and you better write reflexive. And then hopefully you can see that you have a green side, a red side, and a blue side. So the triangles are congruent because of side, side, side. Now that the triangles are congruent, you can say that an angle is congruent. Isn't that exciting? Isn't that fun? Okay, number 2. All right, same deal. I'm trying to prove a part is congruent. That's a side. So in order to say a side is congruent, I need to use congruent parts. Congruent triangles are congruent. And in order to say that, I need to say that the triangles are congruent in the picture. Is that an S up there? I think it is. SPQ is one triangle, and that's gonna match another triangle, SRQ, okay? I know that I'm gonna say they're congruent. I don't know why I'm gonna say it yet. Actually, I do, because again, I recorded this 20 minutes ago, but you don't know why. So we have to get there. I have parallel lines, which means I'm gonna use angle relationships at some point, okay? I can pretty much bet that it's gonna be alternate interior or corresponding. One of those, probably alternate interior, because we see that more frequently. But I'm gonna do this other piece of information, QPS, this one. It matches SRQ, that one. Fantastic. Do we see how there's a side that overlaps? That's important. So you're gonna say that QS is congruent to QS and it's reflexive. Okay. I labeled my picture. I got my blue angle from what they gave me. I got my green side from what I know about overlapping sides. Now I need to use this piece of information somehow. I need to find an angle. All right, I'm going to choose this one and this one. And it's not really choosing, I don't have a choice, because this angle, both the angles that are sitting on this line, this one and that one, this one's already spoken for. That's the blue one, that was that. The only other choice I had was this one. And the only other choice up here I had was that one. Now, why can I say that both of those are congruent? They are, so I'm gonna write that angle RQS is congruent to angle, what's the other one, PSQ? Okay, I'm gonna say that, but why? Alternate interior. Okay, alternate interior. Now what have we built? We've built an angle, and a side. It flows angle, angle, side. Angle, angle, side. Oh boy. 2 down, 3 to go. X is the midpoint of 2 things right there. It's the midpoint of this and it's the midpoint of that. I count 1, I count 2. That means I'm gonna have definition of midpoint not once, but twice. Isn't that nice? You wanna see someone go insane, you put them in a room for 4 hours and make them do triangle proofs and then actually have them do it longer than that because the phone messed up. It's fun, makes people go cranky pants. I'm trying to prove an angle here is congruent to another angle. That's a part, children, that is part. When I'm trying to prove a part congruent, I'm gonna use that. And before I can use that, I need to say that the triangles are congruent. WTX, it's not a T. It's congruent to WVX. I started, so let's go YZX. I put a triangle sign there first. Okay, don't know why they're congruent yet, but I know this much. And of what I filled in, most of this is free points. You have to think a little bit for this, but I hope that this is becoming second nature. All right. X is the midpoint. X is the midpoint. It means that this matches that, and that matches that. Those are my statements. So my 1 tick mark is VX. That thing is congruent to the other 1 tick mark, XZ. Now my 2 with my 2. WX is congruent to XY. Wonderful. Okay, I can't say anything about these sides because it doesn't give me any information about those sides. So it's not side, side, side. My side, side, side dream, you're dead. But what's not dead and alive? Vertical angles. You love to see them. At least I do. They're easy. They're congruent to each other. Vertical angles. How am I going to name them? The left one, V, X, W. I can't just say angle X, by the way. I can't be lazy pants. I can't say angle X is congruent to angle X because which angle X are you talking about? Are you talking about this one on the left or this one on the right? Or how about this one up here, that one down there, maybe this big one? Okay, lots of choices. That's why we have to use 3 letters to describe angle, VXW. It's congruent to angle, ZXY. Now what have we built? We've built an angle that is sandwiched between 2 sides, side, angle, side. This thing is full of sass, which can describe more than one thing in this room. All right, we got a bisect, which means I'm gonna use definition of bisect. You better have it. All right, I'm trying to prove a part. That's a side, people. That is a side, so we're gonna use congruent parts. Congruent triangles are congruent. That's a lot of wrong letters that I wrote there. Congruent parts of congruent triangles are congruent. Maybe I had it right. I got lost. Before I can say that, though, I need to say the triangles are congruent. Triangle, KJM, is congruent to triangle, LJM. All right, don't know what goes there. I'll figure it out. All right. I don't want to do the bisect thing yet. I'm going to do this one, JMK. JMK. That's talking about this. And the other thing it matches, it's talking about that. Okay. Now I'll do the bisect thing. The bisect. JM is cutting KJL in half. KJL is this angle. So if L is cutting that in half, boom, 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 boom. All right, that's my statement for definition of bisector. KJM angle. KJM is congruent to angle LJM. All right. The last thing, overlapping side, it's important. JM, congruent to JM, reason reflexive. What have we built? We've built a dumbbell. We have a bar that is red, and on one side of it is a blue corner, and on the other side is a green corner. When I have a dumbbell like this, it is angle, side, angle. One more. By the way, I think there was multiple choices that you could have chose for one of these, unless we haven't got that. I think this one, I think you had multiple, I don't remember. One of these had multiple choices. I did a really good job the first time. This one also has multiple choices, but I'm not really gonna dive into them because I'm running late on time, which is unfortunate. But I'll still show you how to do it correctly. But just know that maybe there's some secret answers in here that you might be able to find, and it's probably correct if you dig that deep. Okay, I've got this taken care of. D is the midpoint of some stuff. So I'm gonna have the definition of midpoint. That one's not optional, you gotta have that one. I'm trying to prove a side is congruent to a side, so that means I'm gonna use that C thing. Congruent parts of congruent triangles are congruent. Before I can say that, I need to say that the triangles themselves are congruent. So I'm gonna say that BCD is congruent to triangle BCDEFD. Okay, don't know that yet. But D is the midpoint of BF. So I'll say that BD is congruent to DF. Wonderful. Now I just have this left. Okay. It gave me vertical, or sorry, not vertical angles. It gave me parallel lines for a reason, because I'm gonna look for angle relationships. Okay, somewhere, I need to use probably alternate interior to get from either this one to that one or that one to that one. But I'm a huge fan of vertical angles, and I like finding them. So this one up here, that's vertical to that. I'm gonna use it, okay? Lots of different ways to do this one, but I'm using the vertical angle. So I'm gonna describe that angle, the green one, the top one, as angle BDC. I'm gonna describe the bottom angle as I want BDC, so I'm gonna do FDE. That's an E. The reason those things are the same is because they're vertical. Okay. So unfortunately, one vertical angle doesn't get me there. I do need to use an angle relationship. I'm gonna find alternate interior, but it's up to you which one you wanna do, because I'll tell you, you can choose this one, F and B, and you can get the correct answer. It's just gonna be a different answer that goes here, but I'm gonna use this one that is long and skinny, this E and C, because I don't know why, I'm just doing it. So I'm gonna say that angle E is congruent to angle C. My reason is alternate interior. They are both on the inside of the parallel lines. The transversal that joins them, this one's under, that one's over, alternate interior. And now what I've built personally here is I've built an angle, goes to an angle, goes to a side. Red, green, blue, angle, angle, side. Okay. If you chose to do B and F instead for your red angles that are congruent, you'd be correct, but angle, angle, side won't be your answer. It'll be slightly different. Maybe you can figure that out. Okay, that is it. Round 2 for this one done. Hopefully it recorded, and now I'm gonna throw my phone out. So, hope you have a good day, children. Oh look, it is recording. Wonderful.